Okay, so seeing this problem, the key things that jump out at me here is they're saying that the dataset is normally distributed. So therefore I know I'm using some technique from my normal section, chapter 8.5. So now they're saying they have a mean of 500. That was nice of them to give us that. So we can just jump straight to that. And they're telling us there's even a standard deviation of 100. Find the probability that a randomly chosen test taker will score 650 or higher. So to do this problem, we need to answer that question. What's the probability that someone will get 650 or higher? Now, we could go through and use that whole horrible formula, but the easier way to do it is to change this to the standard score. So a standard score formula, if you recall, is the data minus the mean divided by the standard deviation. So in this case, our data value is 650. We're going to subtract it from the mean of 500 and divide by 100. So therefore, we're going to end up with getting a z-score of 1.5. So now what we're going to do here is, that was kind of all side work. What we're going to do over here now is change this. So z, because it's number of standard deviations now, is greater than 1.5. So how do we translate this? We go to our z-table. So on our z-table, we're now going to find the value of, oh, there it is, 1.5, already had it marked. So there's our value of 0.4332. So now we know that this has the value of 0.4332. But we have to remember what that means. What that's saying to us is at the value of 1.5, the area between the mean and 1.5 is 0.4332. But that's not what we want. They want to know who got higher. They want to know this area. So it's key for us to remember that the graph, any normal curve, represents 100% of the outcomes, so all the area underneath the curve adds up to 1. So therefore, if we're looking from the middle on, that would be 0.5. So this area in here was 0.4332, which would mean, excuse me, this area right here would be 0.5 minus 0.4332. So results that would result in the answer of 0.668. So let's go over here. So now we know that this is going to equal 0.0668. So I hope that helps. I hope that makes sense. Best of luck.